Welcome to the ThinkDesign Sheet Metal Advanced tutorial. In this e-tutorial about advanced sheet metal, you will be shown all those commands that have not been included in the basic e-tutorial about sheet metal. Furthermore, you will be shown how the sheet metal module does not constrain you to follow a unique predefined method, but how you can instead approach designing in a number of different ways. For example, you can design an object using the sheet metal feature from its very start, or, on the contrary, you can receive an object, for instance, designed by someone else using the standard solid features. Apply on it the sheet metal features you need in order to make it possible to bend the object itself. Let's now focus on the Extruded Flange command, which enables you to create a flange starting from an open profile containing only lines and arcs, with one of its endpoints on an edge of a solid. The flange thickness is automatically taken from the solid. Now let's open file 1_extruded flange and let's apply the extruded flange command. We can select first the edges with the tangency chain, which means with a single click all the contiguous edges that have tangency continuity in the joints will be selected. When the type is set to tangency chain, all the edges in the tangency chain are automatically selected no matter where you click to perform the selection. Once the profile to be used has been selected, let us confirm by clicking Apply, and let's see what we get. As you can see, the flanges are created only on the linear edges and not on the curvilinear ones. And now let us redefine our feature. So we shall right-click on the Extruded Flange in the History Tree panel and select Redefine Feature. Let's replace the tangency chain selection with a multiple selection of single edges. In the Type drop-down list, let's select Edges, so as to select directly on the model each edge on which a flange has to be created. Let us then select the edges by clicking on each of them, and then let us rebuild the model by clicking the green traffic light on top of the selection list. In short, we have modified the object, telling the system we want the flanges only on the edges we have explicitly selected. Let's now redefine our feature once more. Right-click on the Extruded Flange in the History Tree panel and select Redefine Feature. In order to show that we can easily change the extension of the flanges, in the Extension drop-down list under More Options, let us select First and Second Distance. We can specify an initial and a final distance respectively from the first endpoint of the first edge and from the second endpoint of the last edge, or selecting the At Each Edge checkbox, specifying the distance of each flange from the first endpoint of the corresponding edge. Let's then input different distance values at each edge so as to show that it is possible, and then let us rebuild using the green traffic light on top of the selection list. To sum up, we have been able to create flanges by extruding a profile along selected edges, each at its own distance from the first endpoint of the corresponding edge. For our convenience, let us now activate the Name Views dialog box. Let us redefine the extrusion once again, because in this case our goal is to remove distances and to define a full extension by setting the extension drop-down list to full. As for the type for the selection of the edges, we shall set it to chain in order to automatically select all the contiguous edges, even if they are not in tangency. So, as you'll see, when we rebuild the model, an extruded flange is created on each edge, except the curvilinear ones. We have created all the flanges, and since the miter checkbox is selected, also the miters between each couple of edges are created. Now we shall go on bending the object using the unbend command. Then let us set the top view and let's fit it. we can see the development now of our unbent object. We shall select the face, the fixed faced edge, and fit the view, and then we'll redefine the feature by unchecking the miter box and rebuild the model again. As we can see, all the miters have been removed from the plane development of the object. And now we can rebend it using the rebend command, and we can newly get the solid, and we can observe that the miters are no longer there. Take a look. Now we select the face, which must be fixed, and here is the object, and as you can see, the miters are absolutely no longer there. So that's all for this exercise.